Hello friends, today I'm going to explain some of the programming using shell programming. First thing I want to show how to find Armstrong number using shell programming. So this is the code I'm using here. Actually, Armstrong number is if you add all the digits in the number. If it is two-digit number, if I square those numbers, each digit number, and add it together, I should get same number as it is. So if I take 153 1 square plus 1 cube plus 5 cube plus 3 cube, I need to get 153. So I'll get it as 1 plus 125 plus 9 3s are 18. I'll get it as 153. So this is how coding. First I'm reading it from I'm taking a number from the user. I'm reading it in C and storing that C in X. I'm taking this is sum r and n equal to 0. I'm checking out if x is greater than, while x is greater than 0, I'm doing this one. I'm just dividing it. I'm getting the remainder here. I'm using percentage to get the remainder and storing it r, so that it's 153 in the sense I'll get 3 as the remainder and I'm storing it r, and n and expression I'm just doing it. I'm for 3-digit number. Actually this is for 3-digit number, so I'm doing the multiplication it and storing it. And so 3 cube is 18, so I'm storing it n, and some value is 0, so I'm adding sum to 18, so it will be like some value will be 18. Then I'm dividing the expression with 10, so I'll get as 15 as remainder. X goes here, the same it happens. Then 5 cube will be coming and adding as 18 plus 125 will be adding 18 plus 125, you will get it as 143. Yes, I'll get it as 143 or something. 153 you'll be getting. Then again if you 154 you'll be getting. Then if I would add 1 you'll be getting as 152 I'll be getting. Then I add 153 it will be coming here. So I am now, after this I'm checking if the sum is equal to C, because I'm storing C here. I'm displaying Armstrong number. If not, I'm displaying it is as not an Armstrong number. So we'll just run the code here. I'm just as 153. It shows as Armstrong number. I'll just go for 147. It is not an Armstrong number. So this is how it's going. So next we'll see whether to find a number is a prime number or not. You know, if a prime number, it will be divided by only 1 and itself. It will not be divided by with any other number. So I'm just using the same logic here. I'm taking the enter a number, I'm taking it and reading the number in num. Then I equal to 2, I have given it. Then I'm checking it as less than number. I should be less than number. Do I'm doing it as, I'm just, here is my logic. I'm taking the number and dividing it with 2 and I'm increasing the value. If it is equal to 0, then I'm displaying it. It is not a prime number. If it is not equal to 0, if it is equal to 0, I need to display it as not prime number, because nothing should divide it except that number. Since it is divisible by that number, I'm not displaying it. If not, I'm displaying it as prime number here. Yes, so I'll just run it. I will just go for high number. 89 is a prime number. Then I'll go for like 100. It is not a prime since it is easily divisible by 2. Next we'll go for perfect number. Perfect number in the sense all the factorials of the number add except that number. If they added all the factors of the number, if we add it, we should get that number again except that number. We need to add all the factors of the number, we'll get the number. So I'm just having the same, I'm dividing it with the I. If it is equal to 0, I'm adding it. If it's not equal to 0, I'm going to the next number. So while echoing divided by 2, I'm just dividing by 2, reading it in, because we know it. If it is maximum, they will be like, we'll be taking only half. It is like 16, we'll take only half. Up to 8 only we'll be taking, because if we take 9, it will never go there, because 9 2s will be like 18. So if we take 16, so it will go up to 8, will not go up to 9. So I'm taking as divided by 2. I'm checking with each and every number. If it is equal to 0, I'm adding it and I'm increasing the I value here. I'm done. I'm checking it if sum equal to n. Here I'm displaying it as perfect number or it is not a perfect number. So we'll just go for it. Enter a number. I'll just give as 6. 6 is a perfect number because 1 plus 3 plus 2 will get it as 6. Then maybe also 26 also is not a perfect prime number. And then I can go for 28. Maybe 28 is also prime number. Like, we'll check it out. Because 1 plus 2 plus 3, 3 plus 4, 7, 7 plus 7, 14, 14 plus 14, 28. So this is how you got it. Next perfect number, we'll check we'll give this is a program where I'm taking 3 subject marks and I'm displaying the sum of the marks, then average, and even I'm displaying the grade. If I'm taking here, I'm reading up to here, I'm reading it and I'm adding it and I'm displaying the sum here, and I'm displaying and I'm adding and storing it in sum. Now I'm taking the average because 3 subjects, I'm dividing it by 3. I'll get the average and dividing it. Now I'll take the average. If the average is greater than 90, I'll display grade. Else if it is greater than 70, I'll be displaying grade. Else if it is greater than 60, I'll be C grade. Else if it is greater than 50, I'll displaying D grade, or else I'll be displaying F grade. So this is how I graded. We'll check it out. SH like 98, sorry, 98, 80, 76. Average is 54 and average is 84. Then I am displaying as grade as B here. Now we'll go for a factorial number. Like, 5 factorial is 125. Like 1 into 2 into 3 into 4 into 5. So this is how, if we add it, we'll get that number. For 4 it is 24. The same way you'll get it. So I'm just doing the same thing here. Not equal to C, till it is not equal to C. I'm decreasing the number. I'm reading it. I'm taking the number from the user and storing it in fact, and I'm initializing n equal to and C equal to 1. And if it is fact is not equal to C, that is equal to 0, I'm doing it C plus 1 BC. I'm just increasing the C value, and I'm doing it as n into C. So I'm doing it n into C. I'm storing it in n value will be 1. So from C value will be 0. First it will be 0. First it will be 1 here, then 2, then 3, then 4, then 5 up to the fact value. So we'll check it out here. SH factorial, enter the number. I'll give as 4. It's 24. 4 3s are 12. 12 into 2, 24 plus 24 into 1, 24. We'll go for like big numbers. Sorry, something went wrong here. I'll just go for 10. 10 factorial is 3 6 2 8 8 0 0. This is how I got it. After factorial, we will go for sum of squares of n numbers. This is the program. Logic is I'm just increasing the number and I'm squaring it and adding it here. I'm just checking it is less than not equal to n. Then I'm multiplying I value here. I value will be 1 and n value will be here. Then I'm increasing the I value and I'm adding the sum to sum. So here I'm squaring the number and here I'm adding summing it with the before number and increasing the I value here. So I'll just go for 5. It's 55 because 5 5 is 25 plus 4 square 16, like 35. 41 will be coming. 41 plus 9, 41 plus 9 will be 50. 50 plus 2 square will be 4. 54, then 1 square will be 1. So I'm getting as I'll just go for 7, so it's 140. So this is how I got it. Sum of squares. Then we'll go for electric bill. I'm taking the units from the how much unit they have consumed. I'm taking it from the user. If it is less than 200, equal to 200, I'm just displaying into 2.00. If it is greater than 200, I'm for every unit I'm just charging 2 rupees. If it is between this one 200 and 100, I'm charging 1.50 rupees. If it is less than 100, I'm charging it as 50 paise, and I'm displaying the amount. Unit I'll go for 50. It's 25 here. I'll go for like 700. I'll be getting 1400 because into 2 rupees, right? Actually I'm taking into 20, so you'll get it as 1400 here. So this is how created. Thank you.